Good morning, everyone. I am Araki Jersen and I am pursuing MSc Data Science at Christ DMTB University, Pune, Lavasa. And I have written this research paper. The topic is an analysis of Levenshtein distance using dynamic programming method. And this project is under the guidance of Dr. Preeti N. And today's presentation, we are going to see introduction, objective, dynamic programming, subproblems, algorithm used, result, and references. Introduction. First of all, what is Levenshtein distance? What is edit distance? And what's the difference between Levenshtein distance and edit distance? Levenshtein distance is a simple metric which can be used to find the distance between two strings based on the string approximation. And edit distance is a way of quantifying how two strings are similar to one another. For both Levenshtein and edit distance, the distance can be quantified by the minimum number of insertion, deletion, and replacement operations it's required to transform one string into another. For example, we have two strings. The one is source string and another one is target string. If the source is test and the target is also test, then there is no operation needed because the strings are already identical. Else, the source is test and the target is 10, then there is one substitution needed. That is sufficient to transform S into N. The difference between Levenshtein distance and edit distance. For Levenshtein distance, the operation cost is 2. For edit distance, the operation cost is 1. And this project addresses the problem of determining the distance of regular language, that is the set of words accepted by a finite automation. Mostly these methods have been used for string matching, speech recognition, spell correction, and plagiarism detection. Next objective of this project is quantifying how two strings are to one another by counting the minimum number of operations required to transform one string into another. Next, dynamic programming. What is dynamic programming? Dynamic programming is an algorithmic technique and it is used where we have problems which can be divided into similar subproblems. And these are the subproblems in this case. For example, here we have two strings. The one is monkey and another is donkey. If the last characters of the strings are similar, then nothing much to ignore the last two characters and count the remaining for the strings. Else, the last characters are not similar, then we have to consider this all operation like insertion, deletion, and replacement on string 1. Mostly this method has been used for optimization. Next, algorithm. Here I have executed this algorithm with an example. Example for edit distance. Here we have 3 steps. The first one is initialization. First, I have constructed the matrix. Here we have 2 strings. The one is March, the other one is cart. First, I initialized first row and column. Next, the next step, processing. First, we have to examine each character of the string. If there is a match, then it will take the diagonal value. For example, here March has A and cart has A. There is a match. So it will take the diagonal value. The value is 1. And if there is a mismatch, it will choose minimum among top, left, and diagonal value and add 1 to it. For example, the cart has T and March has M. There is a mismatch. So it will choose the minimum among the diagonal value and add 1 to it. The minimum value is 3 and the final value is 4. The next example for Levenshtein distance. This example similar to the previous example. Here we have 2 strings. The one is intention and another one is execution. If there is a match, then it will take the diagonal value. If there is a mismatch, then it will choose the among top, left, and diagonal value and add 2 to it. The difference between both Levenshtein distance and edit distance. I have already explained. For edit distance, the operation cost is 1. For Levenshtein distance, the operation cost is 2. The next result for Levenshtein distance. Here, X identify the source string, which is intention, and Y identifies the target, which is execution. And finally, the distance in the matrix upper the right corner 8. For example, the distance for Levenshtein distance 8. And next, references. These are the references I have used for this project. That's all. Thank you.